2.3, problem number 32. We could get into a really long explanation of this one, but I got a feeling most of you guys would prefer the short version. So in this section here, which we brushed through notes pretty quickly on, they talked about all these different rules here for evaluating limits, and one of them was the product rule. We didn't spend a whole lot of time on it, but 32 says that they want us to show that the product law cannot be used to evaluate this particular limit in this problem. And the answer to, or the reason why that's the case, everybody, has to do with this little screenshot here that I just stole out of your textbook. This is on page, oh shoot, I was just there a second ago. Let's take a look here, everybody. This is on page 72 of the textbook, if you did feel like looking this one up, whether you have the hard copy or the PDF. And if I zoom in on that a little bit, here's what that one says. The important thing we need to focus on here is at the very beginning of this blurb that it has here at the beginning. Oh, that box won't go away. All right, here we go, guys. Theorem 1, basic limit laws. This is important here, and in fact, I don't think I really mentioned this in our notes, and I really should have. If the limit as x approaches c of f of x and the limit as x approaches c of g of x, if they both exist, then you can apply all these rules, including the product law right here. And the product law is what says that the limit of a product is equal to the product of two individual limits. But all of that is predicated on this hypothesis right here, if the first limit exists and the second one exists. So if we talk about what's going on with this function here, guys, let's play around with it for just a second. The limit as x approaches pi over 2 of the first part right here, x minus pi over 2. So the question now should be, does that limit exist? And the answer to that one is yes. This is a continuous function. It's a polynomial. It's linear. So we can just plug pi over 2 in for x, and pi over 2 minus pi over 2, of course, is 0. So no problem so far. The real problem, though, comes in the second part. What is the limit as x approaches pi over 2 of the tangent of x? Now, I'm hoping you guys remember enough about your tangent graph over the last couple of years to know that this is a problem here. But just in case you forgot this, let's go through a couple refreshers here. Tangent, everybody, unlike sine and cosine, does not have an unlimited domain. Tangent has a whole bunch of vertical asymptotes, and the first two are located at plus and minus pi over 2, vertical asymptote here and vertical asymptote here. And between those vertical asymptotes, let me switch back to blue here, we hit the point 0, 0. The tangent of 0 is 0. We go through the origin at a 45-degree angle, a slope of 1, and then it kind of looks like a y equals x cubed function, although it has the vertical asymptotes that stop it from getting wider and wider. So that's what this thing looks like in one iteration, and I better go just a little bit further to prove my point here. If you look at the spacing between these two asymptotes here, guys, from negative pi over 2 to positive pi over 2, that's a spacing of pi. You can continue that spacing over here, another pi units, and that will help you locate your next vertical asymptote. Pi over 2 plus pi is going to be 3 pi over 2. Now, there's a reason this is kind of relevant, and I'll get to it in a second here. Switching back to blue, halfway between two vertical asymptotes is another x-intercept. That one happens, it looks like, at pi, and again, we pass through that at a 45-degree angle. And we have that curve here and this curve here. Now, the only reason I brought all that up is to focus now on what's happening as x approaches pi over 2. So let me switch colors on you here. Let's go to this lime green. As x approaches pi over 2 from the left, I might start this big fat dot right there, and as I move it closer and closer to pi over 2, you can see that my y value is approaching positive infinity. However, as I jump over here to the right of pi over 2, and now I start approaching pi over 2 from right to left, my y value is approaching negative infinity. And since the left-hand limit, as the left-hand limit appears to be positive infinity, and the right-hand limit appears to be negative infinity, the left and right-hand limits at pi over 2 do not agree with one another, and therefore we would say that the limit does not exist as x approaches pi over 2. So back to this particular hypothesis right here, you can only use the product law if this limit and this limit both exist. Well, the first one does, but the second one does not. And that's the reason why you cannot use the product rule to evaluate this particular limit, and you'd have to rely on graphical or numerical methods to come up with that limit instead.